XML is a data interchange format that you probably use all the time and don't even realize it. The last time you've listened to a podcast or opened a Microsoft Word document, you've been using XML. Today we'll explain what XML is. Welcome to Kopek Explains Software, the podcast where we make computing intelligible.
All right, so this week, Dave, we're talking XML. Let's start at the beginning. What is XML?
XML stands for Extensible Markup Language, and a markup language you can think about as kind of a meta language. It's data about data. XML in particular is a very flexible markup language. It can be used as an interchange format for all kinds of different programs, but each program needs to define a specific XML schema, and a schema defines what's allowable in a particular XML document. So XML is this flexible format that we can use for a variety of different purposes, but we need to go and define a schema to define how it's going to be used for one particular purpose.
So what are the components of XML?
So an XML document is made up of elements, and elements you can think about as parts of a document. Now, how are those elements actually defined? They're defined using what are called tags. And there's going to be a start tag and an end tag to define one individual element. And that individual element might also have some metadata about it, and we call those attributes. And then an element can actually contain other elements. Now, if you're starting to get lost here, let me give you a very concrete example. Let's say we were defining an XML specification for a trivia game, and the trivia game could have different question sets. Well, then one type of element we might have is a question. And each question element, let's say it's a multiple choice trivia game, might have multiple answer elements that are combined within it. And so, for example, if there's 4 possible multiple choice answers for each question, then each question element might contain 4 answer elements. Now, there might be more that we want to know about the question, such as how difficult it is. So maybe there's an attribute that's part of a question element that's called difficulty, and it tells us if this particular question is easy, medium, or hard. So you can see how together between questions and answers and these attributes, we're actually building up some structure. And once we have that structure defined, we then have a way of creating a format that can be interchanged between, let's say, somebody who creates the questions and the programmer who's going to use those question sets to actually display the questions to the end user. So XML is for defining interchange formats, and it's a meta format for defining multiple different kinds of interchange formats. We might use it for a trivia app, but we might use it for many different kinds of apps. And those other kinds of apps are going to have different kinds of elements that their XML documents contain.
So what makes XML different than a programming language?
XML is not a programming language because it does not contain actual logic. So there's no programmatic control. There's no decisions that are made, such as, based on this, I'm going to do that. Instead, XML is just a way of defining data. It's a way of interchanging data in a common format. Oftentimes, the original schema will actually be defined by a programmer. So a programmer, the person making the trivia app, is going to decide what the schema is for the XML question sets that maybe even some users will generate. And then anyone who follows that schema will be creating question sets that are usable by that program.
So it defines what something might be looking like.
It defines what the data is. It's not necessarily what it looks like. It's going to depend on how the XML document is interpreted. So there might be one program that uses the same trivia sets in a different way and displays them differently than another program does. But if they both follow the same XML schema, then they can both use the same question sets.
So when was XML developed and who developed it?
XML was originally developed in the late 1990s by the W3C, that's the World Wide Web Consortium. And they're a standards body that defines many different standards that are common to the World Wide Web, including the most important one, HTML, but also standards like CSS and several of the web APIs that we use every day. Now, the World Wide Web Consortium was looking for a flexible format that could be used for multiple different internet services. In particular, XML has really found a stronghold in web APIs. So oftentimes when you're writing a third-party client app, so maybe I'm writing an app that accesses some of Google's services, the data that's sent over the wire for my app to use might actually be encoded in an XML format. And then my program will need to know how to interpret that particular XML format. So web APIs are a very common use of XML. But when they were originally developing it, they were actually seeing it as a potential combination with HTML. So HTML, which we've talked about a little bit in a prior episode called How Does the Web Work, which I'll link to in the show notes, and we'll probably have a future episode about HTML in particular as well. But HTML is how we define the structure of a web page. And they were thinking, well, what if we could have the structure of web pages just be another particular format of XML, so a particular XML schema. And they called that way of defining web pages XHTML. And it looked for a while like that was going to be the future of authoring web pages. But in the long run, a newer version of HTML came out called HTML5, and it has actually supplanted XHTML as any kind of popular standard, and XHTML is not used that much anymore. So originally, the World Wide Web Consortium came out with the XML standard, and that was in the late 1990s. But what we found since then is that it's found a stronghold in web services, but also in file formats for just general apps. For example, most modern Office suites use XML-based formats. So Microsoft Office, OpenOffice, LibreOffice, Apple's Office programs such as Pages and Keynote and Numbers, they all use XML-based formats for storing their files.
It's not just the Office suites that are using XML, though.
Yeah, XML is really widely used. I mentioned a lot of APIs that developers connect to use it. We talked about Office suites, but it's also used in RSS. RSS stands for Really Simple Syndication, and it's a format for basically broadcasting when new articles are available on a website. And it's often used for blogs. So oftentimes you have a blog, people can subscribe to your RSS feed that defines what new articles are coming out over time on your website. And then you can have something called an RSS reader where you can download all those articles. A lot of news sites will syndicate their content inside of RSS feeds, so you can always get the latest news through an RSS reader if you don't want to go to their website. But an interesting place RSS is used also is for podcasting. I think we're going to get into podcasting on a future episode, maybe even next week. But podcasts are also coming out actually in these XML documents called RSS feeds. And so every time you access a podcast, what's really happening is you're downloading an XML document that says, here are all the episodes that are available. And there's a specific schema for what a podcast XML file looks like. And all podcast players and companies that help you host podcasts are really just creating or reading those XML files.
And then it's also used as Android layout and SVGs.
Yeah, so there's file formats that have become common that are open standards in the same way that that some of the early XML work was. For example, SVG, which goes back to the World Wide Web Consortium as well, is a format for storing vector graphics. And we talked about vector graphics in a prior episode too, so I'll put a link to that in the show notes too. But XML can really be used for any kind of file format. It's so broadly used. It's used for configuration files on iOS and macOS. It's used for layout files for what the user interface looks like in an Android program. It's used for so many different purposes. It's a really flexible format. Anything that you can have a structure for, that you can define using elements, attributes, and elements within elements, you can define using XML.
You've talked about how schemas define XML formats. Can you dive a little deeper into what a schema is?
Yeah, sure. So a schema is going to be what makes one particular XML format valid. So for example, let's go back to our trivia app again, because I think it's a really clear and simple example. What needs to be in a trivia app file for it to be a valid question set? What types of elements are allowed? What elements can be inside of other elements? What attributes do those elements need to have? So the schema defines a very, very stringent set of structure. And as long as an XML file follows that structure, then we know it is a valid file for that schema. And so a very common task that programs that use XML do is schema validation. They take an XML file, they check it against the schema, and they see if it's actually a valid file. If it's not a valid file, then the data is not in the places that the program expects the data to be, and then the program is not going to be able to parse the data and use the file. So sometimes a lot of programs actually that use XML are very strict about what they expect the schema to be. Sometimes there's fallback mechanisms where, okay, if some part of it didn't exactly match what was expected for the schema, maybe we can have some kind of error handling and some way to get around that. But generally, programs are pretty strict about expecting each of the individual files to match the particular XML format schema to a T.
So the schema is the standard that the programmer creates.
Exactly. The schema is the standard for the particular XML file format that the program uses. And by the way, more than one program might use the same schema. For example, RSS, right, is an open standard, again, for syndicating usually blogs or news sites or podcasts. And all the different podcast players use that same schema. So that way the same XML file is understandable by any podcast player. In the same way, for example, Microsoft uses a particular schema for Microsoft Word documents. If another program understands Microsoft Word's XML schema, then it might be able to save and open Microsoft Word XML documents as well.
So what does an XML file look like, and how does a programmer use it?
So an XML file is actually just a text file. And those tags that we talked about earlier that define the elements, they have a very common format of just having an opening less than sign, the name of the tag, any of the attributes with equal signs between the name of the attribute and the values, and then a closing greater than sign. If this sounds to you like HTML, it's because it was inspired from the same place as HTML. That's why it comes from the World Wide Web Consortium. So if you went and opened an XML file, it would open in your text editor. And it's pretty human readable. You're going to just have regular text defining the names of the attributes, defining the names of the tags, defining the content of the tags. And so any human being can go and actually edit an XML file. And that's one of the beautiful things about XML, is that because it's very structured, it's easy to parse for machines. But because it's just text, it's easy for human beings to edit. And so if you're a programmer, every common programming language is going to have a popular XML library. And so you're not going to need to go reinvent the wheel figuring out how to interpret this format. You're going to be able to use an off-the-shelf parser that knows how to read XML files, and you're just going to provide it the schema, which also comes in a very predefined format for what a schema is supposed to look like. And it's going to be able, that library is going to be able to check for you as the programmer, does this particular XML file match this particular schema? And again, both the schema and the XML file itself are just text files that are human readable, that a human being can go and modify easily.
So one of the things that's really special about XML is that it's human readable and machine readable.
Yes, that's one of the great things about it. Not every file format is like that. For example, earlier versions of Microsoft Office used binary file formats. And they were not at all human readable. They were extremely specific to each Microsoft Office product, and they were not text files. So you could not easily open them and see what they looked like. So yes, one of the great things about XML is that it's both machine and human readable.
Is there anything else that would be really important for our listeners to know about XML?
I think the most important thing for them to remember is that it's a meta format. So it doesn't just define one particular type of file, it defines a way of defining file formats. And so we have different schemas for different kinds of XML files. And you can go, if you write a new program, you become a programmer, you can define your own type of XML files and your own type of schema. And it's going to be particular just to your program. And if you make it an open format, then maybe other programs will use it too. So XML is a meta format. It's a format for formats. All right, thanks for listening to us this week with one of our more technical topics. Next week, I think we're going to get into podcasting, which is always an interesting topic for a podcast to cover. Looking forward to that. Rebecca, how can people get in touch with us on Twitter?
We're at Kopec Explains, KOPECEXPLAINS.
Thanks for listening. Don't forget to hit that subscribe button, and we'll see you next week.
Have a good week.